All right, this is video 3 for applications of quadratic functions, and this is my third example. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. Couple key terms to pick out is we know we're going to be looking at area. We know that we have a rectangular region, so I'll probably want to draw a picture. We want to find the dimensions, which that means the length and the width. And we know we want to enclose an area, so that means we're looking for perimeter. So step 1. Let's write our let statements. And draw picture. If it's a geometry problem, you always want to draw a picture first. So let's go ahead and do that. Here I have a rectangular region. I know if it's a rectangle, my opposite sides will be congruent, so I can say x and x. And then I'll say y and y. So let's go ahead and write the let statement that goes with that. I'm going to let x represent width and let y represent length. From here, I'm going to use both perimeter and area to set up a system of equations. All right, so now here, let's go ahead and do that real quick. So I know the area is going to be the length times the width, so I know A is going to be equal to x times y. Second, I know my perimeter equals the distance all the way around, x plus y, which yields 2x plus 2y. However, I need to pull one more piece of information out of the problem. It says that you have 120 feet to enclose the rectangular region. That means that I'm going to use 120 feet of fencing to go all the way around. So my perimeter is actually 120. So instead of writing P, I'm going to write 120. Next, from here, I'm going to go ahead and I need to take area is what I'm trying to maximize. So I need to end up getting area in terms of one variable. There's a really easy way to do that. So I know the area, so we need to write a quadratic function. So I know the area equals xy. My perimeter, 120, equals 2x plus 2y. So what I'm going to go ahead and do is solve for one of these variables. So I'm going to go ahead and I'm going to just, how would I solve for y? So I'm going to subtract 2x on both sides. That gives me 120 minus 2x equals 2y. Divide by 2. I'll have y equals 60 minus x. With that 60 minus x, I'm going to substitute in for y right up here. And then I'll have a equals x times 60 minus x, which applying the distributive property gives you 60x minus x squared. Now applying the commutative property to write it in standard form, negative x squared plus 60x. There is my function that represents area. Go ahead and circle that because we need to use it. From here, step 4, we're going to go ahead and I need to maximize this area, which means I'm going to find the vertex. So what I'm going to do here is I know that a equals negative x squared plus 60x. So I'm going to find x equals negative b over 2a. Negative 60 over 2 times negative 1 gives me 30. So my area should be, or my width here, right here, should be 30 because I said let x represent the width. Now we got to find y still. I'm going to use this equation down here because y is already by itself and nice and isolated. Y equals 60 minus x. So y equals 60 minus 30, or 30. So my ordered pair is 30, 30. Those are the dimensions that maximize my area. So let's go ahead and do that. I'm going to say step 5, write a complete sentence, please. The dimensions that maximize area are 30 feet and 30 feet. And we're done. Next, I have one more. We're going to go on to example 4.